Hey everybody! Today what I'm going to do is to show you how to use Excel to do regression. In fact, there's a regression tool built into the analysis Toolpak in Regression, and it's a pretty slick little thing. So I've made a copy of the Stats 101 data, and now what I'm going to do is get rid of all of the variables which are non-interval scale. So I'll keep the respondent. Of course, we won't use it, but we'll get rid of section and gender. We'll keep age. We'll get rid of eye color, smoking, personality, which is actually a rating scale, so it's ordinal. We'll keep the math 30, the English 30. We'll get rid of the stats grade. We'll keep the GPA. It's actually a goofy variable because the GPA is calculated from a letter grade, and the letter grade is ordinal. But of course, colleges and universities always use GPAs as if they were interval scale, and they calculate averages and things like that. And so we will consider it to be interval scale as well. In fact, it's going to be our Y variable. We're going to ask the question, what determines a GPA? And then we'll get rid of the age class, the movie rating. Those are both ratings, and so they're ordinal in nature. Then what I'm going to do is I'm going to open up a spot here at the front, and I'm going to move GPA to the front here. You don't really have to do that. You can keep it at the end, as long as you keep all of the X's together. But it's a good idea to keep your Y variable at the very beginning here. Let me just color it yellow. And then all of my X's are together, so I've got the age, the math 30, and the English 30. They're together as one block. Let me color those orange. There we go. Now the respondents, of course, we're not going to use in our analysis. But let me show you now what we're going to do. Oh, hey, before we go further, remember that you got to make sure that for every row, you've got a Y variable and 3 X variables. In other words, there's no blanks there, no missing values. So what I always do, as you know, is that I always color a particular row, and then I'm just going to click anywhere on the GPA column, and I'm going to sort. And I'm going to run right down to the bottom here. Now, I actually don't have any missing values here, but you would go to the bottom here, and if there was any missing values in any of these bottom rows here, you'd get rid of those rows. Then you go over here to age, and you sort according to age, and you do the same thing. Check the bottom and remove any rows that have missing ages or any other values. Math 30, sort, everything's fine. English 30, again, you can click on any cell and sort. And finally, I'm going to go back and sort by the respondent column. You don't have to do that, but I just want to make sure that ours look the same if you were to do the same thing. And if I go to the top, I should see that those cells that I had colored green, they all stayed together. So everything looks good. All right, now that I've done that, I've set up my data the way I want to, let's go into Data, the Data tab. Data analysis, and of course you may have to add that in. Mine looks a little bit different than yours, probably because I'm using a Mac, but it's almost identical, and it has the same options here, so the same procedures like ANOVA and correlation and descriptive stats and the t-test and all that kind of stuff. And then about 2/3 of the way down, we've got regression. So I'm going to press OK. And I've actually done this before. Actually, let me get rid of this stuff so I'm starting afresh. Sorry about that. All right, so this is what the thing would look like when you first opened it up. And what we'll do then is choose the Y range. Now the Y range will start with the label GPA in row B1, and it's going to go all the way down to row 101 in my case. The X's are the corresponding values in column C, D, and E. So C1, D1, E1, all the way down to row 101, like that. All right, click the Labels button. Don't worry about the constant. Don't worry about the confidence interval. And this stuff down here on residuals, we'll get to that in a later video. But the last thing that I'm going to do is just click on the output range here. And notice that I'm down at about row 71 here, so I'm going to scroll back up to the top, just so I'm not searching all over the place for my output. And click and OK. And there's my output right there, everything that I need. Now, I'm going to just go over to the next page where I've cleaned this up a little bit here. And so what I've done here then is I've taken everything to 3 decimal places, with the exceptions of the observations and the degrees of freedom in the ANOVA table, because those are integers. The other thing that you can do here is, if you take a look at these columns here, you'll notice that they're duplicated. And so I can get rid of those last 2 columns. What I usually do is just find some blank cells just above it or below it, and then grab the little copy area down here and the box and just pull it down, and it disappears. That's great. I'm going to make this just a little bit bigger. There we go. All right, so let's take a look at the regression statistics. Some of the interesting stuff here. Here's your R-squared value. Now, your R-squared, 0.388, is usually expressed as a percentage. 38.8% of the variation in GPA is caused by the 3 variables, age, Math 30, and English 30 together. Now, if this was a simple linear regression means that you have one y variable and one x variable. So let's say you had just GPA and age, and you didn't have Math 30 and English 30. So if you look down here, you'd have the intercept and you'd have the age, but you wouldn't have these last 2 rows. So if it was a simple linear regression where you only have one x variable, then if you took the square root of r squared, you'd get this guy here, the multiple r value. And that's actually the Pearson R, the correlation between GPA and age when you're dealing with a simple linear regression. You look at the sign of age and it's positive. So a positive slope means a positive correlation. If this was negative, then this would be a negative R. Now again, when you're dealing with multiple linear regression, then this has a meaning which isn't going to come into this particular course here, so we're not going to use that. But in simple linear regression, it's the little r. So the r squared is the important one, and it's 38.8%. The adjusted r squared is a little smaller, and we'll talk about that in a lecture. It is just really a penalized factor for having variables in the model which are insignificant, that aren't adding anything to explaining GPA. Over here we've got the ANOVA table. So here's your SS values. SSR is 14.256. SSE, another name for error, is residual. So this is actually the SSE term of 22.494. And then this is SST. Here's your degrees of freedom. So this would be the number of regression, the number of x variables. And then this would be n minus the number of x variables, p minus 1. And this is just n minus 1. Now, the numerator of the f star is if you took SSR divided by p, degrees of freedom, and you'd get the numerator up here, so 4.752. And then for the denominator, if you took SSE divided by n minus p minus 1, you get the denominator. And then finally, if you took 4.752 divided by 0.234, you'd get 20.279, which is way out there in the upper tail of an F distribution. And that's shown by the significance F. That's the p-value. Let me just type that right here. So this is the p-value for the ANOVA test. Now, this green line here Doesn't, of course, normally come with the output. I put that in myself here. But anything above the green line is an aggregate measure. So the R squared is an aggregate measure looking at all of the x's together in their explanation of GPA. Same with the ANOVA test, is it's looking at all of the x's together and how they explain the GPA. So they're aggregate measures. The individual tests are shown down here. So for instance, here's the intercept, your B naught value. The B naught value is 0.529. Here's the SB naught value, the standard deviation. And so if you took the B naught divided by the SB naught, you'd get the T star value for the intercept, and then the P value. The P values are always two-sided because when you're dealing with multiple linear regression, the x's interact with each other. And so you don't know whether they're going to be positive or negative. And so they're always two-sided tests. Here's the confidence interval. And you'll notice the confidence interval for the intercept has a negative lower bound and a positive upper bound. So it contains 0. And that means that it's not, this coefficient here is not significantly different from 0, which of course is supported by the p-value. Take a look at age. Age has a coefficient of 0.013. Standard error, divide by that, you get your T star. Here's your p-value, 7.8%. So this is where we would say that there's a possible relationship between age and GPA because it's in that 5 to 10% p-value range. If you take a look at the confidence interval, you'll see that it goes from a negative to a positive, but this negative is actually really close to 0, so it's almost all positive. We're going to jump down here to English, and English 30 here has a very high p-value, so 56%. So that's not significant, and you can see you've got a negative and a positive for your lower and upper bound of the confidence interval, so it contains 0. But take a look at math. So math has a p-value of 0. And the confidence interval then goes from a positive 0.14 to a positive 0.31. And so this, although it looks like it's really small, it's significant in explaining the GPA of a student. So the last thing I want to do here is just write out the equation that we have. So the model looks like this. It would be the GPA is equal to 0.529, which is the coefficient for the intercept, plus 0.013 times age, plus 0.023 times math 30, plus, what have we got, 0.004 times English 30. Are we missing anything? Yes, for the model we need to put in an E for the error. So this is talking about the actual GPA values and the actual age, math, and English values. And if you plug in the age and the math 30 and the English 30 from a particular row, then it will differ by the actual GPA amount by some error. If we copy this down to here, I'm just going to change this word to line. The difference between the GPA, between the model, pardon me, and the line is that this is GPA hat. And at the very end, we've got no E. So these are what we call the fitted values, the values on the line. So if I was to take this first row here and plug in 26, 59, and 58 into where it says age, math 30, and English 30, then I would get the value which is on the line there. So the fitted value, the GPA that we would expect to have. And it would differ from the 2.5 by the error term, by the E. So I think that's about it. We're going to be talking more about regression in some other lessons, but this is how you do a full regression and how you read the output. And I think I'm going to stop it there right now.